Hello and welcome to the very first lecture in 10th chapter, Exploratory Data Analysis, EDA Part 2. As I said that I will keep this diagram throughout the course in all chapters now onwards, because one should have a clear idea where we are in a data science life cycle. So we are somewhere at this particular point. We are doing EDA and data visualization. Once you do this, that is this purple and maybe red, thereafter you can talk about feature engineering. In EDA, we have done previous lecture univariate analysis, that is analyzing a single variable at a time, which basically involves statistical summary if that variable is a numerical variable, and also categorical. Also, we can get some other statistical summary and some graphical representation of each variable separately. So that is a bar chart, or maybe box plot, or histogram, or KDE curve, or pie chart, etc. Now here we want to talk about bivariate analysis. So what is bivariate analysis? So let us see, starting from here. This part 2 of EDA expands into the study of relationship between two or more variables through bivariate and multivariate analysis. These techniques are crucial for understanding the interaction among variables. Previous chapter, univariate, gives you idea about individual variable, what is the data distribution, whether it is matching with bell curve or not, whether some scales of the variable are same or not, or we will have to do normalization or standardization, whether the distribution of data is such that it will require logarithmic transformation, that is if there is a skew or not. Similarly, this bivariate analysis, as the name itself indicates, bivariate, so two variables, how the two variables interact with each other, and that is extension, multivariate analysis, how three interact among themselves. So interaction between them, how does one variable affect another variable? Is there a relation between them? For example, in human beings, height and weight are usually highly correlated. As the person grows in height with age, then his weight also increases. Okay. Then what are the dependencies in the data set? Are there any patterns emerging? Now slowly we start formulating hypotheses and building predictive models for building predictive models. So this stage will lay down the foundation for feature engineering, how to do feature engineering, and what kind of hypothesis is likely to work for our model creation. For example, in that employee details data set, which we talked in previous chapter, we were trying to predict the salary based on features. So slowly after doing both univariate and this chapter bivariate or multivariate analysis, we start getting idea that whether a linear model will fit the data, or whether some parabolic or circular model will fit the data, or some other curve model. If the data has some seasonal pattern, then maybe sine curve will fit the data distribution, like that. So let us start bivariate analysis. And in previous chapter also we did that, and here also we are doing that. We initially start just a imaginary type of data frame with only two variables. Obviously, such data frame we will not see in industry. X and Y only two are there, because in industry, for example, that employee details data frame which we saw, that we know that it has several cleaned employee details. It has several columns, not just two columns. Okay, but we start with simple. So X column is filled with normal distribution of floating point numbers, which are randomly selected from range 0 to 1, and the total number of observations would be 100. Y will also be normally selected floating point numbers from range 0 to 1, but in Y we are adding this noise, something different. Okay, so 0.5 times normal distribution. So this is now not just one normal distribution, but we can say that two normal distributions are being added, so that the two columns X and Y do not have identical data distribution. Let us create a data frame and let us view it. So if you view it, this kind of X and Y are created. Okay, this is 100 observations for X, and these are 100 observations for Y. Correct? Now once you do that, you can plot. Now for a single variable, what do we plot? We used to plot box plot, histogram. For more than one variable, important to know is how those two are related with each other. So that is just like X and Y, and you have to plot a graph of X versus Y, or Y versus X. So that is called a scatter plot. So scatter plot is plotted in this manner. The steps remain more or less equal, but this time will not use SNS library. Everything will be done by matplotlib.pyplot. That is the PLT. Okay. So first decide figure size, then decide the type of plot. I am deliberately hiding the code. So decide the type of plot. Type of plot is already decided that it is a scatter plot. Then decide plot title, decide axis, And then if you want to show the grid, then write grid equals true, and finally display the plot by show command. So actually it is very simple, and you can see that first command itself is plt.figure, and in which you have to use fixed size as the argument, and you have to pass a tuple with the width and height of the plot which you want. Then plt.scatter, okay, and dfx and dfy. So x and y. Now first is always x variable and next is always y variable, and this alpha is equal to 0.7. That will just decide if the resultant, if the scatter plot dots, because scatter plot is nothing but several dot will be plotted on xy axis, xy plane. So whether they will be transparent or not transparent. So we will see if you vary alpha what happens. So that is which plot, then plt.scatter for which variable, then from the my data frame take x variable always first, then y variable second, and decide some transparency by using alpha. Then plot title, so plt.title, and then you write title scatter plot of y versus x. Then decide if you want to show the grid. Then plot labels, then plt.x label is x and plt.y label is y. And if you want to show the grid, then plt.grid in bracket you write true. Okay, and then finally display your plot. If you display, it appears like this kind of scatter plot. Y variable, that is according to this equation that is displayed on this axis, and x variable is displayed on this axis. So that means each point is nothing but a collection of xy coordinates. This point will have some x value and some y value, which are decided by these two equations. Similarly, this point somewhere here will also have some x value and some y value, and again they are decided by these two equations. So we get a scatter plot like this. Now I try to change the alpha and make it say 1.0. Let us see what happens. First note down which kind of this is there. So then if I make 1.0, you can see that immediately transparency has become 0, or that means the darkness has become 100%. Very dark points are there. And similarly I put this 0.01, okay, and very light points will be created. So light that they are hardly visible. They are there. If I just slowly increase this, then you will be able to see them. Now you are seeing them slightly, and if I make this a 0.15, then they will be still more visible. Okay, so now this is useful sometimes, particularly when multiple different xy plots are to be pasted on same graph paper. Then you can select different transparencies, so that while describing to learners or stakeholders, you can always say that the faint one is the scatter plot of this versus this, and the dark points, they show the scatter plot of this versus this. Not only that, you can even change the size of this round, and you can choose some other symbol also. How to do all that? For that I have already told you that you do just this plt.scatter, and instead of finishing the parenthesis, instead of that you write a question mark and press Control Enter. You will see all possible symbols. Here this marker, that marker, when you write none, no marker, then it will not plot anything. Similarly this alpha, that is also, then V minimum, V maximum, C map, norm, then line width, then edge colors, then maybe somewhere color type. Okay, marker type can be dot, some cross, etc. So you can get different shapes as instead of this circular dots. Okay, let me make the alpha 0.75 and keep it. Now this I am deleting. Now explanation, this is a visual representation of how change in one variable is associated with change in another, and it is useful for detecting patterns, trends, or anomalies. Now here, for example, if you say someone asks you a simple question that can you pass a linear graph passing through y versus x, then no, a linear model will not fit this data. Okay, because if it is a linear model and you pass it here, then majority of the data points, say 90% of the data points, should be very close to such a line. But can you pass any line through this data point, say this way, or at 45 degrees this way, or at this way, like that? No, you cannot put any line, right? So as a result of that, the linear models are already ruled out. So I have to choose some non-linear model. So linear regression cannot be applied to predict y from x. I have to choose non-linear model, like maybe SVM is a non-linear model. Don't bother about at present what are they, but it is a non-linear model. Okay, so you have to choose somewhat like that. Now you can also visualize the data relationship using scatter plot. So enhance the scatter plot will Seaborn I have written, but that is not much enhanced actually. Just that previous one was plotted with Matplotlib, and this is plotted with Seaborn. Otherwise, it is also here. That means the previous title was plt.scatterplot. Here the title is sns.scatterplot. Also there the arguments were df and then x, comma df and then y, like this. Here the arguments are x and y directly. So immediately when you write x and y, it will automatically remind you of the third argument, because in same Jupyter notebook x and y can occur in say data frame df1, df2. So which x and which y? So obviously you have to specify your data frame, and my data frame is at present df is equal to this df which I have created. So I am talking about its x and y. And then if you plot this graph, it is more or less similar, not more or less exactly similar. The only thing is that it is slightly squarish, okay, but it is a non-linear distribution of points. Now pair plots. Now this is something important. So between x and y, I can plot pair plot like this. This shows x versus this histogram shows x versus x. You can go horizontally from here and you can go vertically from this x. So you can see that it is a graph of x versus x, and that means it is a histogram of x. That is univariate discussion, okay. And we saw that the distribution is almost normal. Similarly, this lower one is graph of y versus y. You can see horizontally I am going from y horizontally, and then from this y I am going vertically, and I am reaching this. So this is graph of y versus y, or that means graph of y only, univariate. Okay, and that is not perfectly normal distribution. Now that was expected, because if you see these, then the distribution is not normal. That is one, this part is normal, this part is also normal, but we are adding two normal distributions with different initial coefficients. So as a result, you get some this kind of distribution. Now these points are important, that is this plot and this plot, because if you see this way, x, and here from upwards, then this is the graph of x versus y, okay. So this is the graph of x versus y, and similarly if you see this y and this upwards, then this is the graph of y versus x. So this is that scatter plot only. So pair plot is very useful plot, because it can do univariate and bivariate both analysis in a single plot, okay. And for two variables, you may not realize the real importance of pair plot, but for multiple variables, you will see that pair plot is very useful thing. And we will always plot pair plot for every data frame with which we work in our data science projects. So this is y-x scatter plot, exactly like this y-x scatter plot. Okay, there is absolutely no difference. Again, it shows that this relation between y and x is not linear, so I cannot put linear model. Then there is something more. You can find correlation between y and x. Even the equation itself says that x and y must be somehow correlated, because at least initial part of equation looks same. So if you see it, then you will find that correlation by initially using data frame dot core matrix. So correlation matrix is equal to df.core, and once df.core is generated, that is just a number, I mean collection of numbers. So if I just take this in other cell, and here I just print out what the df.core is, then you will understand what it is. So df.core, correlation matrix, because we are storing the df.core in this variable, okay. So if I plot the outcome, then this is called correlation matrix. Again, what it shows that between x and x there is 100% correlation, because that is common sense that every variable will be totally correlated with itself. Then similarly between y and y, again there is 100% correlation, because each variable is totally correlated with itself. Now between x and y, so between x and y, this is one correlation between x and y, and similarly this is also one correlation between y and x, okay. And you can see that they are not much correlated. Y and x, they are not much correlated. Now this correlation is the basis of data science. So if my outcome variable, y is my outcome variable, is not much correlated with my feature variable, x is my feature variable, so y and x, they are not much correlated. That is what this shows from x and up or downwards from y. That means that there must be some other variable which are explaining the y, because x can only explain around 13% of the variation in y. In very rough language, I can say that x can only explain around 13% variation in y. But what about the remaining 87% variation? So there may be some x1, x2, x3 and other variables which are other independent variables, and my dependent variable or response variable may be depending on that also. That is the meaning of this kind of low correlation. But if I get here 0.99, that means I can say that this x alone can explain 99% of the variation in y. So in that case, I would say that I do not need to either create new variable or ask the client for more data, because I think 99% of the variable in response variation in response variable is correlated with x, okay. Now once the correlation matrix is generated, this is also nice way of correlation matrix, and I would always insist that you read the numbers. But if you don't want to read the numbers and show the same thing as a picture, then you can represent this as a picture by using something called heat map. So heat map is written in this manner, plotted in this manner. SNS library is required. SNS Seaborn dot heat map equal, and then in bracket what argument, then correlation matrix you will put annotate is equal to true. So annotate is equal to true means these values which I have written, they will be shown in the boxes. C map is equal to cool warm. Now that is just various color patterns are there, and line width is equal to 0.5. That is also you can change it for appearance sake, and you get this kind of heat map. Again, it shows that between X and X itself, 100% correlation, but between X and Y blue square, the correlation drops to only 13%. This scale, color scale, shows that as you go towards bluer and bluer, the correlation is weaker and weaker, and as you go towards red side, the correlation goes on increasing. Now, this is about bivariate analysis as such. So, bivariate analysis means what you study. Then you study scatter plot, then you study pair plot, you find correlation matrix, and you plot heat map. Now, is this only enough, or is this much discussion enough? Then in previous chapter we saw that normal data set will never have only two variables like these two. Normal data sets, this was our employee data set cleaned. Then you can see that it has so many variables, and the response variable is suppose employee salary. So we are not predicting y on the basis of some single x, but we are trying to predict y on the basis of x1, x2, x3, x4, x5, x6, and x7. So how to do bivariate analysis for that kind of case? Now that can as such also be called multivariate, but because there are multiple variables, but we do multivariate also by taking two at a time. So that means relation between salary and the date of birth, relation between salary and the date of joining, relation between salary and qualification, salary and age, salary and marital status, and salary and performance rating. So we will do this kind of bivariate analysis, taking one response variable and one feature variable at a time. Okay. So for which I am loading the data set which I had already created in previous chapter. This is the discussion about what do we include in bivariate. But again, and this is the script by which bivariate analysis is done. But I have taken each step of that script separately in different cells of Jupyter notebook, so that we can understand gradually and step by step. But you should understand that why this code is not written, then there is no need to write this code. First of all, if you insist that you want to write, then you just give prompt to your ChatGPT or AI tool, and it will give you the code. How would be the prompt made? I have an data set named employee details.csv, or actually if I write then this data set cleaned employee details.csv, because so I have a data set cleaned employee details.csv. Okay, and then I want to do bivariate analysis of this data set. Give me the complete steps in Python code format, and whenever some diagram or plot is to be generated, don't generate in my Jupyter cell notebook, but instead create a separate directory in my Jupyter notebook named employee details underscore bivariate, and store all plots inside this directory, employee details underscore bivariate. Clearly currently there is no such folder existing, so it will create the folder and it will put inside subdirectories will also be created based on the type, and it will put the plots rather than displaying here below. It will put the plots in those directories. Then you can open them, and one by one you can do the discussion. So this is how the script will be. Again, if you see, the script is completely data agnostic. Data agnostic means today I am importing this CSV file, but tomorrow I can import another CSV file, but still rest of the lines of the code are applicable. Okay. And that is the reason why I said that coding is not a big deal. In every large organization, mostly there is a lot of legacy code. So we just have to use that ready-made scripts. Of course, some bugs may arise here and there. So you will be asked to manage them yourself. And sometimes, very rarely, a major upgrade may come. For example, organization wants to switch from R to Python. So in that case only you have to write everything from scratch. Otherwise, most of the time in organization, you will not be coding, but you will be debugging existing code, whatever, and upgrading. Okay, so in existing code, new features will be added, and wherever some bugs are detected, you have to debug them. But currently, I have put that whole script, long script in the markdown, and instead of them, I am doing step by step. So that we will do in the next chapter. So this is the real bivariate analysis that will start in the next chapter as it is done in industry. Okay, so here also I will change the name. It should not be employee details, but cleaned underscore employee underscore details. Okay, fine. So we will start from here, load this file, which we have already obtained in previous chapter, univariate analysis, and we now want to do bivariate analysis for the same data file. Okay. So thank you, and we will see each other in next chapter.